All right, so the mirror equation is essentially a mathematical way in which we can locate images, we can find the height of images, we can even analyze the SALT, the image characteristics, based on the numbers that we get without having to draw any diagrams. That's kind of a nice thing to do sometimes. Now, I'm not going to make you derive this equation. This particular equation, it's actually two equations, it's actually three equations. These equations, well, this unit on optics used to be in the grade 11 university physics course, all right? And then when they shuffle things around, they put things in different places. They took it out of the grade 11 university physics course, they put it into the grade 10 science. But when it was in the grade 11 university course, I would make the students derive these equations from their pictures using laws of angles like trigonometry and all kinds of stuff. You can get these equations mathematically, and you can get them right from the geometry of the ray diagram. I'm not going to make you guys do that. You guys don't have enough practice in math. It's a little complicated, not a big deal, but yeah, you don't have to worry about that. Like I said, these are actually three equations. The first one contains DI, the image distance, how far the image is from the mirror. It contains a DO, the object distance, how far the object is from the mirror. It contains an F, the focal length. Question? Yes, because that defines everything. Yep.
Is that a 1 or an I?
It's an I. Right there? That is 1. 1 divided by DI. Correct. It's a, you can think of it like a fraction, all right? 1 over DI. I like to think of it as an inverse. I like, when I get you guys to calculate it, I like to have you guys use the inverse button, all right? There's a quick and easy way to do this calculation without having to get into the mess of fractions. It can be done with fractions, and I'm sure lots of good mathematics teachers would be telling you to find common denominators and all that good fraction business, but I'm going to tell you a really quick and easy shortcut on how to use your calculator. Yes, all the math teachers would be frowning and absolutely losing their mind that I'm showing you a shortcut on your calculator, but I just want you to get the answers. And I'm not worried about your ability to solve fractions. So the first equation relates the image distance to the object distance to the focal length. The way we read this one, I say, the way I've been taught even when I was a student, 1 over di plus 1 over dou equals 1 over f. All right? And it's not really di, but we just say di because it's fun to say. Well, in physics it's fun to say. Maybe not in biology. But in physics it's okay. So, di, distance to the image, do, distance to the object, f, focal length. The second pair of equations relates the distance to the image and the object to how tall the image and the object is. So there's a relationship there. If the image distance is big, then the image height is big. It makes it a huge image. If the image is far away from the mirror, the image gets really big. Capital letter M stands for magnification. It's simply a factor of how big the image is compared to the object. Magnification is equal to HI over HO, or high over ho. It's just the way we say it. So if I have a really big image and it's bigger than the object, then the magnification is greater than 1. If I have a magnification of 2, the image is twice as big as the object. It's made it bigger. If the image is smaller than the object, then I'll have a bigger number on the bottom and a smaller number on the top, and I'll have a fractional value. I'll have 0.5. So if I have a decimal value, the image is smaller than the object. If I have a situation where the image is exactly the same as the object, I'd have a magnification of 1. They would be the same. Okay? It turns out the magnification is also related to how far away the image and the object are, but there's a factor of negative in there, right? So the magnification can be determined by the image distance and the object distance, or by the image height and the object height. Very often the way we solve a problem is we're given the focal point of the mirror, we're given where the object is, find out mathematically where the image is, just like we would when we did ray diagrams. We would then put it into this equation using negative di over dou. We would find the magnification, and then we could solve for how big the image is, its height. So we could then solve its height. So we are using these kind of 3 equations step by step to solve for all of the interesting information that we want to know about an image, where it is and how tall it is. All right? Okay? So a couple of things to note. If the image distance is negative, because we can come up with a negative number, it means that the image is virtual. It means that it's actually found behind the mirror. So according to the mathematics, if you have an image that is in front of the mirror in the real world, it would be a positive number. If you have an image distance that's behind the mirror, it will be a negative number. All right? Okay? We can have the magnification have a negative value. If the height of the image is down, where the object was up, that makes it inverted. So if hi is negative, it means it's upside down. That will make the magnification negative, which means it's inverted. Okay? One other sign thing that I want to add to this that isn't on here, so I'll add it at the bottom. If f is positive, you might think f is always positive, but not necessarily. If f is positive, it's concave. It's a concave mirror with the real focus out in front. If f is negative, then that means the focal point is actually behind the mirror in the virtual world, and that is convex. All right? So the f, the sign of the f is dependent on whether I've got a concave mirror or a convex mirror. I can do that with my hand. All right? So let's do some practice problems. And and this is where the new part came in. I actually changed this PowerPoint moments before you came in because I wanted to add some of these extra problems. And I have no idea how this is going to work out. I actually slapped these numbers in here moments ago, so hopefully all the mathematics works. So just put example, all right, e.g. And what I'd like you to do this one at a time. I know I've got a big table of it here, but let's deal with f equals 2.5, di equals 5.0, and ho equals 1.5, and they're all in centimeters. So just write that down. It doesn't have to be in a table form. I put it in a table form because I wanted to make a bunch of examples quickly for you. So you just put example 1, write f equals 2.5 centimeters, di equals 5 centimeters, ho equals 1.5 centimeters. Just write that stuff down. All right, we okay with that? Don't write down the rest of the examples. We're going to only do one at a time. You're going to be okay?
Yeah.
A little sleepy?
I don't know. I'm not feeling great.
Just not feeling great. All right. It's okay. Mr. Sanders might be more caring, but because I'm Mr. Petrus, I'm not concerned about that. All right. So now let's solve. If I know di and f, I can get do. So let's go through the problem. Let's write down our formula. 1 over f, and I'm going to write it with 1 over f first because that's just the way I did it for years and years, even though I had it flipped around, is equal to 1 over di plus 1 over do, right? 1 over f equals 1 over di plus 1 over do, all right? And I want to solve for the do. Let's fill in our information. 1 over 2.5 equals 1 over 5.0. Oops, sorry. Oh, are you kidding me? I've put them down as di's. I wanted them to be do's. There's my first screw up. I've told you the image distance. Don't worry about it. Don't change it. I've told you the image distance, but normally we know where the object goes. But we can still solve it this way. It's not that there's anything wrong with it. But for my next example, I think I'm going to switch these over to DOs. Let's keep going. Not a problem. We can still do it. What we're doing here in this question, I guess, is we're saying we know where the image is. Let's find where the object is. That's okay as well. Plus 1 over DO. I want to isolate DO. So I'm going to bring this 1 over 5 to the other side. In other words, I'm going to subtract 1 over 5 from both sides. Does that sound mathematically familiar to everyone? I'm going to kind of do this kind of in long form, but I'm hoping we can shorten this up as you guys get doing it. That means I'm going to do minus 1 over 5. And on this side, I'm going to do minus 1 over 5. Everybody kind of catching what I did there? And that means that this 1 over 5 minus 1 over 5 is gone. So because I don't have a whole lot of room, I'm going to move it over here. That means I have 1 over 2.5 minus 1 over 5.0 equals 1 over f. Does that look okay to everybody? So I brought this to the, not 1 over f. It's 1 over do. 1 over do. Sorry about that. Everybody catch what I did there? I used the wrong variable there. 1 over do. All right? We got it? We're okay with this? Okay. So how do we solve for 1 over do? Well, there's many different ways we can solve this. And like I said, the mathematicians in the room and in the building would be saying, we need to find a common factor for 2.5 and 5, and then we need to add those up, and then we need to take the reciprocal, blah, 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 blah. There is an easy way to do this. On your calculator, there is a button, and it looks like this, 1 over x, all right? And your iPod or phone might not have that button. If it doesn't have a 1 over x, you're looking for a button that looks like this, x to the minus 1. Oh, excellent. So you need to find 1 over x or x to the minus 1, and it might be a second function button. Have you located the 1 over x? Find it. You must find it. Oh, I don't like the fraction buttons. Well, see, those machines can be done using the fraction button, but I don't like using that. You got to have a 1 over x here. Let me see in the light here for a minute. There it is, right there. X to the minus 1, right there, boom. X to the minus 1 or 1 over x. Did you find it? Yeah. Excellent. Have you found the button? It could be a second function. That's okay. You'll be fine. 1/x, like this. Yes. So here's what we want to do. You want to press 2.5 and press the button after that. Excellent. I don't need to know the number, but thank you. That's good. Then press minus. And then press 5 and press the 1 over x button again. Okay? So what we've done is, we've put in the 2.5 and we've done the inverse. which is what we need to do. Then we told the calculator to subtract from that 5 and then the inverse of 5. Have you done that? You haven't done that? Okay, press equals. You should have a number now. What's the number? 0.2. Everybody's got 0.2? That means 0.2, and I'm going to put a 0 on the end because we know it's a 2 significant digits, is equal to 1 over DO. Now that's not the answer. That's equal to 1 over DO. So we need to take that number and we need to flip it as well. Now, don't clear your calculators. Have you cleared your calculator? Good. All you need to do now is, because the number's in the calculator, press that inverse button again. And it'll flip it back over. What do you get as a number? 5. That's the correct answer. Oh, I'm going to do it again. I love that. Who just did the wait what? That's awesome. I love the wait what. He's like, well, huh? Who's that, huh, what? That's good. Did we get the answer 5? Okay. So we got DO equals 5.0 centimeters. Let's run through it again together. Are you ready? Okay. 2.5 inverse. You're not playing along. You're just saying yes. Okay. Minus 5 inverse equals. That's not the answer. That's the inverse to the answer. So invert it again. Don't clear the calculator. Invert it to get this to the top. Do you get 5? Awesome. That's much better than... That is truly, again, entertaining. I am entertained. Jillian entertains me every day. You guys got that taken care of? You guys going to troubleshoot this? Nice. Okay, so that's how we get the DO. Do you have a calculator, Wilson? I'm going to be doing all kinds of examples. Who doesn't have calculators out there? You got to have calculators, people. You got to have calculators. You've got to, here, they're right here. So you've got to come and get them. I'm not going to deliver them to you. You've got to be able to do this stuff. This is a participation class. It's not a passive, I don't know what it is. Yes?
What happens to, like, the one minus 5? Like, what?
I thought you guys said you were going to troubleshoot that back there for me.
I mean, like, in the next, like, when we're writing it out, it's just, like, I'm like, minus over 0.5 minus 1 point over 5 equals that, and then it, like, just, like, leaves. Like, in the next one.
I'm going to continue this one, and we'll work on another one, and then we'll go and take care of that issue over there. Okay, so I now have DO, all right? I'm going to clear the screen because I want to keep going and solve for the rest of things right now, and I want to do it on the smart board. So I'm going to clear the screen here for a moment. So let me just get rid of this writing. Clear ink, clear. So we now have DO is equal to 5. Nice. What would you like to calculate next? I now have F, DI, and DO. What do you want to get next? What's that? DH. I have a DH up there. Nope, let's try that again. DI. I have DI. That's fun. Yep. M. Sure, let's calculate M. Are you going to ask me how to use your calculator again, Jillian? By the way, I'm recording all of this. So I'm going to let your parents know so they can listen to the chaos in today's lesson.
Will DI always be the same as DO?
No.
It just is there?
Yes.
Okay.
What equation do you want to use to find M? Yep. I don't have high, so I can't use high over ho. Yep. Negative DI over DO. Negative di over do. Because I have di and do. Negative 5.0 over 5.0. That's fun. What do we have for a number? Yep. Negative 1. Hey, that's kind of neat. that means the magnification is 1, which means the height of the image is exactly the same as the height of the object, except it's upside down. Did we see that in our ray diagrams? Yes. Where was the object? It was right at C. And notice the DI and the E are the same at that point in time. And notice that it's twice as much as F. It's exactly what we would expect. Let's now find the height. M is equal to HI over HO. Oh, here, I'm going to put here a -1, except that's the bad color. -1. And -1 is equal to HI over 1.5. We're not going to use any fancy inverse anything for this. We're just doing straight up math. I'm just simply going to multiply both sides by 1.5. Right? Everybody's okay with that mathematical action there? Which means those cancel out and HI is equal to -1.5. -1.5 centimeters. And therefore HI is -1.5 centimeters, which is what we would expect. It's completely upside down on the same size. Yes? Yes, it means it's the other way. That's right, it's down. Yep. You're not confused. I'm going to clear it, and I'm going to change my DI over to the D over here. You're not confused. For this second one, as I stated, I want to move this over to here. No, you're not confused. This is your generation's response to anything that is a little hard that you have to work with. So whenever your generation, ignore that fake Mr. Petrus there. I'm not even dressed like Mr. Petrus. Whenever your generation encounters anything that's a little bit difficult, you claim that you're confused. It's just that you're lazy and you don't want to actually try hard at it. No? Am I wrong? All right, we're doing this again. Nope, no rebuttals to that. You're gonna tell me. All right, what do you got? I'm gonna tell you this stuff. Second example, number 2. F is equal to 22. And this time I'm going to tell you the DO, 15. And the HO is 12. All right? So, again, I'm going to start with my first equation, this time to solve DI. Does somebody want to tell me the equation because it's just fun to say? Come on, you guys want to participate in this fun stuff. It's right on your paper. You just have to flip back and read it. What equation am I going to use, Tim? 1 over F equals 1 over di plus 1 over dou. That is the most awesome physics equation that there can be. 1 over di plus 1 over dou. Let's start filling in our information. 1 over 22 equals, this time I want to find the image distance, 1 over di and plus 1 over 15. I am now what am I moving here? What's moving to the other side? Yep. And it's going to become negative, right? So I'm going to have 1 over 22 minus 1 over 15 equals 1 over di. Here's where we use our little inverse trick. Yep. Because we can't. They're fractions. You can't do that. You have to get common denominators, and then you have to figure out what that common denominator is, right? Remember all that good fraction stuff? Do you really want to do that? That's why I teach you how to use your inverse button, right? Okay, has Jillian found her inverse button?
Yeah, I figured out it. I figured it out before.
Have you got an inverse button?
Yeah.
Have you got it figured out? Okay, so 22 inverse minus 15 inverse gives you a number. You know what? I really don't care about that number. You don't even need to write it down. All you got to do is inverse that answer, right? So 22 inverse minus 15 inverse equals, it gives you a number, invert it with the inverse button, and just simply tell me what the DI is. Jillian.
I got negative 47.
Negative 47? I have no idea what the answer is. I made these up moments ago. Negative 47.14. There's only 2 digits in here, so negative 47 is awesome. Nothing wrong with that. So are we all getting negative 47? Wilson, did you get negative 47?
I got 15%.
It's good stuff. That is good. That's good. I don't even know why I asked. Yes. 22 inverse, then the minus button, then 15 inverse, then equals, just the way it looks. Here, follow me. 22. Yep, press the inverse button. Press the minus button. That's the button with the little line that goes across. Okay. Then 15. Did you get it? Oh, okay. Are we okay? Did you inverse that?
Oh.
You have to press the equals after that. You've got to go 22 inverse minus 15 inverse equals. Yay! Isn't this fun? All right. The image is negative. What type of image is this? Nope. It's virtual. It's in behind the mirror. Right? I'm going to clear the screen. We're going to do the rest of the calculations. Clear the ink. So what did I just get here? I've got here 15 and negative 47. Is that correct? Okay. Let's get the magnification. Magnification is, what are we doing for magnification? It is high over whole, but I don't have the high still. Negative di over do. Negative di over do. And what do we got here? Negative, what is di? Negative 47 over do 15. Notice the 2 negatives. Yep. Yep. 3.4. 3.14. 3.14. Don't mind the fact that that's pi. That has nothing to do with anything. Jeez. Talk about confusing the world. Right. It's not pi. Thank you. This is a positive magnification. What does that mean? It's upright. And it's bigger than 1, which means it's big. It's big and upright. That means we must be really close to the mirror to make a big upright image. Let's figure out the height of the image. M is equal to high over ho. Are we boring you now at this point? We've done the second example, and Kayla is falling asleep. 3.14 HI. What's the height of the object? 12. So HI is equal to, I'm not rearranging that. You guys tell me what the answer is. What do you got? Yep, Marissa? 37.68. We really only have 2 digits to all of these. So 37.6, I'm going to round to 38 centimeters. Okay? It's really big. Press the equal sign. Yes, Jillian. Well, there are decimals, all right? But let's say we used a ruler that didn't have millimeters on it. Let's say when I measured all these things, the ruler that I was using didn't have millimeters. And if I take some numbers that don't have any millimeters associated with them, when I get an answer, I can't magically all of a sudden know the millimeters of the answer. Did you see what I mean? So in proper scientific fashion, we call this significant digits. When you get an answer, you should always round it back to the number of significant digits that are in the question, because I can't get more digits out just by calculating. You see what I mean? So that's why I round it to that, because I didn't know the millimeters for this, and I didn't know the millimeters for this, so I really can't know the millimeters for that either. That's why I round it like that. Yes?
How would you not have the millimeters though? Like, what you would just...
Doesn't matter whether the question is not how. It doesn't matter whether there's a reality to this. Don't bend my ruler, I'll lose my mind. It doesn't matter how. It's that the numbers that I've chosen don't have millimeters, and so we don't know what they are, and so we cannot have millimeters magically created by a calculation. It's against the rules of calculation. You can't have millimeters generated if you don't know the millimeters of your numbers you put in the equation. I would have put 0.0 if it was 0. I would have put 0.0, but I didn't, because I didn't know the millimeters. Another question out there. Yep.
So then if it does have millimeters, you can't get it?
Yes, that's correct. Yep, because it means that I used a ruler that had millimeters, and therefore you can calculate them.
Okay.
Yep, yep.
So in the first one, you could have...
In the first one, you could have 1 decimal place, because I used a ruler that had millimeters. You see the logic? Excellent. All right, let's do another one. This is fun. I want to move this one. No, let's leave the DI for this next one. Actually, you know what? We're running out of time. Let's jump down to this one. I want to do this one right here because it has a negative F. So I want to do that one because it's got a negative F. No, it's not any trickier. The math's exactly the same. Yeah, we're going to leave the DI the same. We'll leave the DI the same. Oh, wait a minute. No, I got to change this. This is 15. Negative 12, 15, 25. Negative 12. Somebody take care of that troublemaker. Dou is 15.
Oh, I put die.
F is negative 12. Dou is 15. HO is 25. Okay. So, what does the negative for the F stand for? If the focus is negative, what does that mean? Yep. It's a convex mirror, right? It's a diverging mirror. Excellent. The equations are the same. 1 over F equals 1 over dou plus 1 over die. Actually, I did it backwards, didn't I? It's 1 over die and 1 over dou. It doesn't have any effect. Doesn't matter if you flip them around. They're just added, right? So 1 over negative 12 equals 1 over 15 plus 1 over di. Again, you'll notice the first step is always bringing that other one to the other side, right? 1 over d, oh sorry, I'm going to do that differently and I don't have an eraser. 1 over negative 12 minus 1 over 15 equals 1 over di, and I'm hoping we can go straight to the di. Negative 12, invert. Because we're starting with the negative here. The focus was negative. I did, but I started with a focus of negative 12, and I'm bringing the 15 to the other side.
Oh, I did it that way. Oh, no, then the DI would be negative.
You then end up with a negative DI. That'll get you into trouble. in your answer. Correct. You round it to the nearest whole number. You're right. It would actually, it would have been 3.1 because of significant digit rules, and I'm not teaching you all of the significant digit rules right now. Just don't sweat about it right now. But you're right. You're thinking very well. That's a good thing that you're thinking of. You're doing good. 12. Negative 12. You got an answer? What do you got? Negative 6.6. So I'm going to write it as negative 6.7 centimeters. And you're all going to go, wait, I thought we didn't know the millimeters. We deal with what is called significant digits. And in those numbers, there are two significant digits. And I'm going to round to two significant digits. You will learn more about this in grade 11 chemistry. I will harp on it all on and on it. How do you know? You know what? I will do the. No, I'm not telling you all the rules. I'm not telling you all the rules because the rules are quite complex, and I'd need about 3 lessons to teach you all the rules. If you were to put a 7 there, I'd take it. I'd take it. You'd put a 6.7? I'd say great. I'd have issues because you didn't round it properly. I would probably accept that as well. What I don't want you to put is negative 6.666666666 all the way across the calculator. I don't want you to put that because that means that we're not just getting millimeters out of it, we're getting hundredths of millimeters, and that makes no sense whatsoever. Let's quickly keep going. We're getting down to the last moments here. So let's, hopefully as I'm blabbering away here, you figured out what the magnification was. Negative, what is it? Negative d over di? Or di over dou? Negative di over dou. Negative, what was the di? 6.7? Negative 6.7. Negative 6.7 over, what's the do? 15. So negative and a negative cancel out. What's the magnification? Yep. Yep. 0.46. 0.46. Nice. That's 2 significant digits. That's good. That's a good number. We need to keep those digits. Because you use 6.7? That's okay. Yours was negative. Negative? No. It can't be. That's a negative. That's a negative. 2 negatives cancel each other out. Okay, let's do the HI. Because you used 6.7 and the person who gave me the answer used 7. Good enough. Good enough. Yep. Okay? Has somebody figured out what the HI is without me putting it in? Yep. 11.5. 11.5. Notice I've got an extra number there, right? Notice how we've been keeping these 2 numbers here? This is actually 3 significant digits. This would be better represented by 12 centimeters. And again, what I'm dealing with is something called the rules of significant digits for scientific calculation. I'm giving you tiny little bits of them. Don't worry about it. Don't worry about it. Homework. There is homework. There is homework, and the homework is right here. Folks, let me point it out to you. Day's work page. All right? On today's date. Don't worry about the mirror equation and ray diagrams assignment. I'm going to move that to Monday. But there is mirror equation practice, and it is simply a page that has a bunch of numbers on it, just like we just did. All right? And you'll be doing the same calculations. We want you to find DI, we want you to find M, and we want you to find HI for those. No, that's practice. We'll take it up together on Monday. Then, on Monday, I'm going to show you how to do scale diagrams, and I'm going to give you then an assignment that I will be marking you on. Okay? So that's practice. That's fun.